This video is on density. Density is an intensive property that depends only on the identity of the substance, not on the amount of the substance. This is because we take two parts into consideration when we look at the density. We look at its mass and its volume. So density is equal to the mass of something divided by the volume, so how much something weighs divided by the amount of space that it takes up. The units on density are going to be grams divided by milliliters or grams divided by centimeters cubed for us. The formula to calculate density is density equals m mass divided by v volume. Looking at a relationship between density and temperature, typically the density of density of a substance increases when the temperature decreases. This is because particles are getting closer together as their kinetic energy decreases or their temperature decreases. However, this is not the case for water, as we know that ice floats. Therefore, the solid form of water is less dense than its liquid form. This means that the density of ice is less than the density of its liquid water. So therefore, density of water is going to actually decrease when its temperature decreases. And for that, we're thankful, otherwise much of the processes that we depend on for life wouldn't happen. So let's do some calculations. Something to help us with our calculations is the density triangle. If we have a three-variable equation set up like density is, where one variable equals another one divided by a third one, we can make this triangle, where we cover up the thing that we're looking for, and then the resulting two variables are either being multiplied or divided by each other. Let's see this in action. A weather balloon is inflated to a volume of 2.2 times 10 to the third liters with 37.4 grams of helium. What is the density of helium in grams per liter? If we look at our equation, or our question, we can see that we have volume of 2.2 times 10 to the 3 liters. So I'm going to record that by V equals 2.2 times 10 to the third liters with 37.4 grams. Grams we know is mass, so my mass equals 37.4 grams. What is the density? So that's what I'm looking for. From my equation, my triangle, I can see that density, when I cover it up, equals mass divided by volume. So density equals mass divided by volume. I know my mass is 37.4 grams, so I plug that in for m. And I know my volume is 2.2 times 10 to the third. And that's in liters. So on my calculator, I'm going to type in my density of 37.4. So 37.4 divided by my 2.2 times 10 to the third, and I'm going to use this E button for this. And my E button on a scientific calculator is above my comma. It's right here. So I'm going to type in 2.2. Zoom out so you can see. I'm going to type in 2.2 second comma, and that brings up this E. This stands for times 10 to the, I'm going to type in 3. And when I do that, I get my value of 0.017. So my density is equal to 0.017, and then I carry my units of grams over liters. So grams divided by liters. Okay. My next example, I want to know what is the volume, so that's what I'm looking for, in cubic centimeters, that's centimeters cubed, of a sample of cough syrup that has a mass of 50 grams. So my mass equals 50 grams. When I'm told that the density of cough syrup is 0.950 grams per centimeters cubed. Density 0.950 grams over centimeters cubed. So I'm looking for volume. That means I'm going to cover up the V in my equation, and I see that volume equals mass divided by density. So my equation, volume equals mass divided by density. So I plug in, my mass is 50 grams. divided by my density of 0.950 grams over centimeters cubed. So in my calculator, I will type in 50.0 divided by 0.950, and I get 526.3157895. Okay. I have to figure out, well, how many decimal places do I need, or how many numbers do I need? I can see here that I have 3 digits, and here I have 4 digits, but that 0 in front really doesn't make sense to count. So I have about 3 digits here as well. So I'm just going to keep my first 3 digits here. So my 526 grams cancel with grams. I'm left with 1 over centimeters cubed. So 1 divided by a fraction, I just flip my fraction over. So I have centimeters cubed. In our third and final example, we are now going to look at 2 different densities, and we want to see, will this ball sink or float? So I have a plastic ball with a volume of 19.7 centimeters cubed. My volume, 19.7 centimeters cubed, with a mass of 15.8 grams. I want to know, will this ball sink or float in a container of gasoline? Gasoline has a density of 0.66 to 0.69 grams per centimeters cubed. So first I need to figure out, well, what is the density of my plastic ball? I know from before that my equation for density is mass divided by volume. My mass is 15.8 grams. My volume is 19.7 centimeters cubed. So I'm going to plug that in my calculator. 15.8 divided by 19.7, and I get 0.802 grams per centimeter cubed. Now I can look to see that the density of gasoline is 0.66 to 0.69. My density is bigger than that of gasoline. So the density of the ball is greater than the gasoline. So the ball will sink.